All right, here's what we're doing. Even before looking at the weather report, I had decided to give the test tomorrow. Mainly, one reason, you guys all whined when I said test on Friday. So it worked for once. I definitely agreed with you. I didn't want to give the test on Friday. As for being ready, I think you're as ready as you're going to be. I don't think another day of reviewing in class was going to help. I did make the test already. There are 23 questions. Most of the 23 questions are this earthquake material stuff. There are about, I think, 6 or 7 that go along with that quiz we took twice last week. So you do need to know ESRT page 5 and page 10 and know the different plate boundaries and be able to read those reference tables, but nothing overly complicated from the beginning of the chapter. So again, chapter 10 is going to be on Thursday. I normally make these review sheets with you. I did decide to still just make one and give it to you for at least part of one for this chapter, so that you have something to review tomorrow. First things first, if you find a spelling mistake, deal with it, because I just made this quickly this morning, so please deal with any spelling mistakes you find. And let's not catch yourself. No, because I don't always catch myself. So anyway, what's on this reference or this review sheet is just some basics. A lot of it goes along with your homework that you had last night. So I did compare the P and the S waves. Yes, it is important to know that the P waves are fast and they arrive first, and they can go through solids and liquids. Whereas the S waves, they're slow. And because they're slow, they arrive second at the seismic station. And it is super important to remember that they only go through solids. I did include the definition of an epicenter. So we're moving on to this box right here. It is a location on the Earth's surface that is directly above the point where the earthquake originates. So it's directly above the place where the plates slam together. We did this part yesterday where 3 circles intersect. That's where the epicenter is. Please excuse my crummy circle drawing here. I just wanted to get my point across. It's where all 3 touch is where the epicenter is. Same thing yesterday, we talked about smallest and largest circles. If it's smallest, it means it's closest to the epicenter, and the largest circle is the one that's furthest away from the epicenter. So you can just look at the size of the circles and know where the epicenter, like how close you are to the epicenter. Now, for all the different kinds of earthquake questions, I can't really put anything on the review sheet about them. I did remind you the difference between arrival and travel time. So travel is how long it takes to get to the recording station. And I emphasized no scrap paper for a travel time question. However, when you get to arrival time questions, that's when the earthquake actually arrives, and you do need scrap paper. I did give an example of how to subtract time. That will be important. I know in lab, a lot of people are getting stuck on the subtracting time part. And then finally, I just reminded you to use ESRT page 11. Keep this handy. We're going to refer back to it by the end of the period. So your homework was page 37. I just wanted to go through that rather quickly so that we can just do one final review before the test tomorrow. So like I was saying, there are a few on here that you couldn't do. I did completely skip over the Richter scale so far. We're going to talk about that a little bit today, though. All right, so this first one, a place within the earth where the earthquake originates. The key is within. What is that vocab word? That is the focus. I will tell you there is no questions on the test tomorrow that you need to know the definition of the word focus. Question 2 is similar but slightly different. A place on the Earth's surface directly above the point in which an earthquake originates is called that is the epicenter. So you do just basically need to know that the epicenter is we refer to it as where the earthquake happens. So it's where the P and the S waves start out on a map. I did say that you could skip question 3. Question 4, which type of waves will not travel through liquids? S waves. Again, you need to know that for tomorrow's test. So I did not have a question 5. You did not need to do question 6. Question 7, name the type of earthquake waves that travel the fastest. P waves. I did also forget to tell you didn't have to do question 8. Question 9, how far will a P wave travel in 7 minutes, 20 seconds? So we just have travel time. So again, when we have travel, I highly recommend not using scrap paper. So we want, how far will it travel in 7 minutes and 20 seconds? So I just asked myself, well, what did they give me? Well, there's travel time right there, 7:20. They did specifically ask about the P wave. It looks like it goes 4,200 kilometers. Again, question 10 now just says travel. They did just give you the S wave for that one. I got 1,300. Everybody good with that one? All right, now an earthquake's epicenter occurred 6,000 kilometers away. What is the difference in arrival time between the arrival of the P and the S wave? So now we have arrival. That's when you use scrap paper. I'll do a quick example for that one just in case we forgot. I'm just going to use my review sheet as the scrap paper because, again, there's nothing fancy about scrap paper. They give me, the only thing they give me was a distance. So I come over here to the distance part. Mark off the P, mark off the S, slide it over to see the time. And I got right between 7:20 and 7:40. So I went with 7:30. Again, though, if you're within 10 seconds, you're absolutely perfect. 20 seconds is slightly off. Do we hear Santa Claus out there? Is that what's going on? Sounds like it. Oh, Santa Claus is much better. Yeah, I would rather have Santa Claus come in. Explain why a minimum of 3 seismic stations is needed when determining the location of an epicenter. I don't know exactly how you want to explain this, but we can go when you have 3 recording stations, there is only one spot where all 3 touch. If you have 2 seismic stations, there's 2 places they touch. So when you have the 3, you can narrow it down to 1 exact location. What evidence do scientists have that indicate Earth has a liquid outer core? What'd you guys say for that one? S waves cannot travel through it. Then you did just need to fill out the chart. Travel time for P waves, I was just looking for fast. Travel direction, these were the push and pull ones. I'll tell you, you do not need to know that for the test, or I've never seen that on the Regents either. And then what can they travel through? They can go through solids and liquids. S waves, they're slow. side to side or up and down. And they can only go through solids. And which statement best describes the relationship between the travel rates and travel times of P and S waves from the focus of an earthquake to the seismograph station? So first of all, let's look at each answer. Question 1, P waves travel slower. No. So how about this one? S waves travel faster. No. So we are left with answer 2 or 4. Do P waves travel faster and take less time, or do S waves travel slower and take less time? Because they're traveling faster. When something's traveling faster, the faster person in a race will take less time to get to the finish line than a slower person. So those are just some basic facts you needed to know about earthquakes. I would like to test your ability to answer some Regents questions about earthquakes. Let's go to page 32. There are multiple questions on the test tomorrow that are similar to page 32. I want you to, for the next few minutes, to go ahead and do page 32. If you would like to work with a partner, I'm okay with that, or a partner or two, as long as if there's somebody who's not understanding, have your partner help you, because tomorrow you need to be able to do this for the test. Okay, for the next few minutes, we're doing page 32. Again, if you want to work together, you can. So we have on the board here what I just asked you to do. So there was a couple ways you could have done the difference in arrival time. You could have just done what we've been doing and doing the subtracting. You could see that P is at 12:01 and the S wave is at 12:02 and 30 seconds. When you subtract 12, the 12 is right here, minutes after noon. Oh. But in the end, it still comes out to the same answers that go on here. So then 12:01, so 30 and then 1. So all you had to write was the difference. You technically did not have to write the arrival time. But one thing that I will warn you about is always check what the scale says. So in this case, it was minutes after noon. This is 0 minutes after noon, 1 minute after noon. So that's one way you could have done it. You could also, if they go up nice and easy like this by ones, you could also just count. Here's 1 minute and here's half a minute. So a minute and a half for that one. Station Y, they were 4 minutes apart, and station Z, 3 minutes apart. To do the distance to the epicenter using the difference in arrival time. So then they're asking you just to use your scrap paper stuff. So you mark off the 0. You mark off the 130. Find where they fit, and mine fit beautifully at 700. If you said 800, you're fine. Don't argue with anyone. And then it wants the travel time for the P wave and the S wave. So here's 700. Go up till you hit the P wave. Go over. I got that getting there at 130, and redo the same thing for the S wave. I got that right at 3 minutes. Maybe I didn't. Let me recheck that one. 700. No, I did get 3 minutes. Oh, you did you? Good.
No, I just did it wrong.
You did the.
I thought we were writing the time for the arrival time down there.
No,
Yeah.
travel.
So that's all that's what I did wrong.
Okay. Then the 4 minute distance to an epicenter, 2,500, which gives you a travel time of 5 minutes for the P and 850 for the S. And wrapping this up, 1,700 kilometers, 330, and 630. Does anybody need me to go through and explain any of those?
No.
All right, then on the bottom, it says in the 3 boxes provided, label the location of each seismograph, X, Y, and Z. So which one is this small circle? How'd you know? It has the smallest, there's a couple ways you could look, smallest distance, or you could also see that it's the smallest arrival time too. This one's X. Let's look at the biggest circle next. Which one is the biggest? Y, because again, biggest distance, so that means this medium one is the middle one, Z. Which one of these letters, E5, G2, H3, or H8 is closest to the epicenter? Right here, where all 3 meet, is H3. How can you determine which one's closest to the epicenter if you were not provided with the time scale? So if you didn't have these times listed, what's one way we could tell? Smallest circle. What's another way? What? Well, what if we don't have that arrival time and have the numbers? Nope, can't fail then. What about station X also shows it's closer to the epicenter than the other 2? Huh? But again, what if we don't have the numbers? So we don't know what the numbers say. What if we didn't have any of these numbers? How could we tell that station X is closer than anybody else? Okay, this right here. So the arrival time difference is shorter. So P and S waves are closer together. Real quick, on the back of your review sheet, there's a couple things that, because I know what's on the test tomorrow, I think you should probably make sure you know. So first thing, guys, where do earthquakes occur?
On the plate boundaries.
Earthquakes occur on plate boundaries. So again, they don't just occur on plates. Or we can say that, why doesn't New York have earthquakes? Not because it's not on a plate, but because it's not on a plate boundary. What does the word convergent mean? What? Okay, so there are subducting and overriding plates, but what does convergent mean? Come together. Divergent? The opposite, they pull apart. Transform. Slide past each other. Where are the youngest rocks?
On the very, the ones that are right on the top.
What's that called? Not a hot spot. Not a fault line. Ridge. Youngest rock at the ridge. Technically, yes, at the hot spot too. I guess it just wasn't the question I had in my head. So they are always youngest when they're on a hot spot, and then the mountains get older as you get away from the hot spot. I don't think I put one of those on there though. I don't remember. And then I'm just gonna remind you. E ESRT page 10. That's the layers of the earth. And E ESRT page 5, that's the tectonic plates. That's the plate map. That sums up what you have to do for the test tomorrow. And that's it.